Let me just do this to pin my own screen. Okay. So we're talking about this specific question. And I guess the best thing to do, because I'm recording this, is to do this. I'm not sharing my screen anymore, am I? No, okay. So this is review number 4. It's got a graph, and there's an open circle right here pointing like that, and then there's a closed circle right here pointing like that. And this point is -2, 1, and this point is 1, 7. And so this question is asking you about the domain and range. I always put questions like this on tests where I give a graph and I ask for domain and range. It's fairly basic, tells me whether or not you understand the general concept. So domain are all the x values, and range are all the y values. All right, and I specifically say, like in the domain, when you look at the sheet, I say be careful with the domain, because if we're tracing out the domain left to right, we're like tracing this out, we need to skip over this gap. There's a gap between, there's no graph here between -2 and 1. And so we need to be careful when we're thinking about the x values. And this is the one that's going to end up having 2 pieces, which I think I heard you sort of allude to. So when I'm tracing out the x values, this line is just keep going that way, right? This line is just going to keep going that way. They go to infinity, in other words. And so we're going to start at -infinity. And then when we're tracing this one out, it stops here at -2. It's got an open circle, so that means we put a parenthesis. And then we're skipping over this gap, and we're going to start up again right here at x equals 1. Again, open circle, so parenthesis, we're going to go to infinity. And so the domain is the one that gets 2 pieces because it's got that gap in between them.
Okay.
And I think you had, does that make sense?
Yep. No, I got that part. It was just the range, because I originally had like 2 unions stopping at 1 and then 7 because they're open. But Ashley told me that since, see how the lines are intersect, therefore it becomes just -infinity to +infinity.
Oh, I see what you're saying. So you were sort of thinking about the first one was like maybe -2 to infinity or something. And then the second one would be -infinity to 7 or something like that. Is that what you did?
No, for the range, I originally had -infinity 1, and then union 1, 7.
Okay.
Yeah, and then I had 7 to +infinity. But since the lines intersect, it just becomes -infinity to +infinity.
Well, if you write down this, like as I wrote this down, you're skipping over, I don't know if you had parentheses or not, I guess technically, but if you put parentheses, you're skipping over the number 1 here, and then you're also skipping over the number 7 here. But those are part of the range, right? Like if we're tracing out the y values here, this one's just going to keep going down, 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 down. So the smallest y value, so this is not correct. The smallest y value is -infinity, because this one just keeps going down. Right? This one stops here, but then this one picks up at the same spot and keeps going up, 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 up. Right? So it goes all the way up to +infinity. So if we're trying to think about like what y values are skipped or something like that, there aren't any, because this one's going to hit all the ones that go down. This one hits all the ones that go up, and they overlap. There's no like gap.
Because they overlap. Because since there are open circles, that's why I assumed you skipped over it. You know what I'm saying?
I see. Yeah. So you're right. So 7, y equals 7 is not in the range of this piece, but it is in the range of this one over here.
Okay. There we go.
And same thing with this. This one's not here, but it is over here somewhere.
Okay. All right. That makes sense. Thank you.
Okay. Sure. Yeah. So just to be clear, again, when we're trying to trace out domain, we're like going side to side and thinking about if we skip anything, in which case, there's a gap, we skip over it. When we're doing range, we go up and down. And so if we're tracing this one out, this one stops, but then this one sort of picks it up. Okay, cool. Other questions about that one, or other sort of graphy domain or range questions? Just while we're on the topic.
Could we do another problem like that?
Sure. So let me just make one up here. So what if we had one that looked like closed circle, kind of does this thing, open circle, and then this one does like closed circle. And let's just have this one go up. And let me put some markers on them. Say this is the point 1, this is the point -6, this is the point, say 5, and let's say that's 2. So just totally made it up. And let's think about domain and range. In fact, what I'd like to do is actually just let everyone think about this for a second. Look at the picture. If you have a piece of paper, that'd be great. If you could maybe sketch down, write down what you think the answer for each one might be. And if you know, when I go over it, if you got it, great. And if not, that's usually a good opportunity to say, oh, I thought it would be this, but now I understand because we clarified it. If you're just sort of watching me do it, it's not usually as useful. So this is a filled in circle. This one's open, obviously, and this one's also filled in. Just to give you kind of 30 seconds to think about that one. All right, so if we're thinking about the domain and we're going side to side with this one, this is where it stops right here, right? So it's going to start at -6. It's got a filled in circle, so we want to include it, and so that's where we get a bracket, right? So we want to include -6 because it's got the filled in circle, it's part of the domain. And then this piece, again, if we're going side to side, it's everything between these 2 points, right, to 1. And then this one just picks up and keeps going forever. And so technically, it's -6 to infinity. Now, if you want to break it up into 2 intervals, that's totally fine. It's fine to put, say, -6 to 1 with an open circle, so it gets parentheses. And then you could union that with a closed circle to infinity. But those 2 things are both the same. Right? Everything between -6 to infinity is also in the second version. So either one of those versions is a fine version for domain. And again, the reason that it could be one continuous thing or 2 separate things is because as soon as this one ends, this one starts, right? So in other words, like 1's not in this domain, but it is in this one, and then everything else sort of picks up, right? The domain is the tricky one. Right? Well, maybe they're both a little tricky. Anyway, questions about the domain part?
So just making sure that doing domain, it's always the x values, and I would have taken 1 either way to either do the union or infinity, like you said for the top one, right?
Correct. Yeah. So either this version or this version. It's not both those things. One or the other of those things is the same. I'm just trying to sort of point out how those 2 answers are equivalent. Yeah. That's why I'm trying to.
What's the y value for the closed circle? I mean, the open circle. There's no y value there.
This one right here?
No, the first closed circle.
This one. Oh, yeah. You're right. Sorry, I got to put a y value there. Let's say it's -7.
Okay.
Sorry about that. Then we need that for the range. Yeah, good point. So we're doing the range then. That's where the range starts, right? So the range, we're tracing out the y value. So we're going bottom to top. And so it starts right at that point, which is now -7. It's got the filled in circle, so we've got the bracket. Obvious about that. But then there's this gap here, right? When we're tracing it top to bottom, we've got to skip over that gap. So this piece kind of comes up and it stops right here at 2 with an open circle. So this is going to be 2 with a parenthesis. And then we've got to skip over the gap, right? So we want to have a union with a second piece. And the second piece starts at 5, closed circle, and just goes up forever. So it's going to be 5 with the bracket to infinity. And there's only one version of that, right? It's not like a either or on that one because you've got to skip over the gap. There's no gap in the domain one.
Could you just remind me what the parentheses means? Because
So, yeah, go ahead. What were you gonna say?
I was going to say the bracket means it's included, and then parentheses means what?
Don't include it.
Don't include it. Got it.
Right. So the 2 gets a parenthesis because it's open, but the -7 gets a bracket because it's closed. Same thing. This is maybe a good one to look at, right? -6 to 1. This was closed. That one was open. Bracket, parenthesis.
I have just a question about number 9.
Sure. Can I clarify anything else about this one before I switch over to 9? All right, let's look at 9.
It's just a simple question. Like
Sure.
the f of g, g of x, or h. Do I have to actually like distribute the values, like, or just plug it in and just leave it as it is?
Just
You know what I'm
plug
saying?
it in and leave it. Yeah.
Leave it. Okay, because it's asking for a sign function, and it says no calculators are allowed. So I wasn't able to figure out the sign unless you just plugged it in, just leave it, right?
You're just plugging it in and leaving it. Yeah. So the questions that are composition questions, I actually didn't write it like this on here for some reason, but I'm going to ask questions like that in the test. And what I write in the test is in bold letters, do not simplify this. Like, don't waste your time simplifying it. It's just trying to see if you know how to plug things into each other.
Okay.
Yeah. If you look at the solutions for that one, you'll see that I'm just plugging them in. I'm not like distributing or anything. So the composition ones are the ones that were due last night. And I was getting a decent amount of emails about those, talking to folks, and I also know a lot of people went to see the tutor last night, which is great. So I don't know if those issues are worked out, or if people want to look at those. I'm happy to, if people want to. Since there seems to be a little bit of a lull in questions, I'm just going to sort of mention a few things about the problems, maybe just run through some of the problems, just say a few things. So there's definitely going to be some exponents questions. That's the first thing here, right? There's going to be a question that looks kind of something like that. And I usually put a radical one on there too. Now the thing with this radical one is you can either treat it like a radical and do the radical properties, or you can change the radicals to exponents and do the exponent property. I usually recommend using them as exponents because that's always, always, always going to work. The second one here, the factoring problem. These are just the 4 different types you might see. There's like quadratics, like this one and this one. This is just a common factor question. And then this one, whenever there's 4 terms, it's factor by grouping. So that's where you just do those 2, you look at a common factor, you do those 2, you look at a common factor, and then there's like a second round of factoring. So anytime you see 4, and I usually put one of those on there too, you want to use the grouping method. Compound fraction, or fractions in general, you do want to know how to add fractions. We need to know how to be able to find common denominators and add fractions for sure. We just talked about this domain and range one. I like questions like that. But there's 2 types, right? So there's domain and range from a graph, which we just talked about. But then there's also domain from functions, like these 2. Right? So there's 2 of those types of problems. Domain means the same thing in both cases, but sometimes doing the function ones people get confused by, although we have talked about those a decent amount in these sessions. You want to be familiar with the vertical line test. So a graph represents a function if it passes the vertical line test. So I could either ask you to draw graphs like this one, or sometimes I put a picture on there and I just ask, is this a function? And you would just use the vertical line test to determine it. There's lots of different equations that we can solve. So there's quadratics like these 2. You either factor those or use the quadratic formula. And then there's all kinds of other equations that we can solve. I put a couple of them here, but there's others too, right? So there's ones with absolute value like this. There's ones with fractions like this. There's ones with roots, which I haven't put on there. Trying to think what else. There's linear equations, which is not represented here. So there's certainly other types of questions and lots of different things you can solve for x. And then there's a bunch of different inequalities as well. And I tried to put one example of each type. This one is a little more straightforward because you're just trying to get the x in the middle. These two require a specific property to be used in the text. Happy to look at that as well. And of course, the last topic is the composition one, which is you're given some functions like this, and then you're sort of asked to plug them into each other. Or you could be given a function that's already plugged into each other, and then you pull them apart, right? So we had those due in the homework last night. Happy to look at some of those as well. Okay, just thought I'd do a quick run through. I'm happy to sort of sit here and still just wait for questions if you're just looking through stuff, but I'm gonna stop talking right now and see what's up.
Question.
Yep.
I forget when it was, but there was it was a problem about graphing, and it had two lines like plotted on the graph,
Mm-hmm.
and we had to like find the function, and like I like wrote out all the x and y values, and I just couldn't figure it out.
I think I know which one you're talking about. Let me pull that one up. Was it this problem?
Yep, that's the one.
So this is a composition of functions problem, and it's a little bit different than the one. It's different than the one that's in this review, because in this one in the review, you're plugging functions into each other, right? And so in other words, notice the instructions here have x's in them. And so the answers are going to have x's in them. This one is different because there's numbers, right? You're plugging numbers into these composition functions. So the answers here is going to be a number. So it's a very different kind of composition of function question where we're trying to get a number. I don't always put questions like this on there, but it is important that we understand how to do this one, I think. So let's just talk about this one quick. So the way we think about this, if I wrote something like this, and I'm just going to kind of type some things. If I wrote something like f of 10 or something, this means you look at the f graph, right, the blue one, at x equals 10. That's what f of 10 means. And so that's exactly the similar kind of instruction that this one has, right? It's f of something. It's just that the something needs to be a number. And so what we want to do is we want this to equal f of a number. And so what we're going to do is figure out what g of 1 is. And then replace g of 1 with a number, right? Because then if we put a number in for right here, then we'll have f of a number, and then we can just look at the graph. See what I'm saying so far?
Yes.
So let's figure out what g of 1 is. So that's where we need to look at the g graph. So this is the g graph, the red graph. And so g of 1, we go to the x value of 1, right? This is an x value right here. And so we go to x equals 1. I don't know if it helps to zoom in on this. This is kind of everyone gets a different graph. This is what mine looks like. So we go to x equals 1, right? This right here is x equals 1. And so the function output at x equals 1 is where the graph is. And so we go up to the graph at x equals 1, and it happens to be right where this dot is. So this dot right here is g of 1, right here, in other words, on the y-axis. And that is at the point y equals 1. Now, how do I know that's y equals 1? Because it's telling me right here that each one of these ticks is 0.5. So it's 0.5, 1. So in other words, what we just figured out was that we now know that g of 1 equals 1 from the graph. So that means f of g of 1, we can just replace this inside part with the number 1. is what this says. So this is really just f of 1. And this is something that's easy to do. We just look at the blue graph at x equals 1.
It's
So we
that
go-
simple.
It's that simple. And so we go to x equals 1 on the blue graph. We go up to the function. It's right here. Right? This is the point 5. Y equals 5. And so f of 1 is 5. Right, so here was the process, just to kind of be clear. No, I'm just typing things out here to try to explain it. But we wanted f of g of 1. We figured out that g of 1 is 1 from the red graph. And so then we looked at f of 1 on the blue graph, and we figured out that that was 5. And so the answer is 5. But I'm just trying to type out here kind of how we got there, right? So we check answer. That's right. Thoughts about that? Can I clarify something there?
No, I think you explained it pretty well.
All right, why don't you take a second and just think about this second one, just to see if it's clear. So it's the opposite in this one, right? So we want to look at the red graph eventually, g, but first we need to look at the blue graph and figure out f of 0. So what is f of 0?
Would it be 5?
So here's 0, we go down to the graph. Looks like it's at -5. 1, 2, 3, 4,
Oh yeah,
5.
-5.
Right, so f of 0 is -5. So that means f, or g of f of 0, we're going to replace this part with -5. Now this is just saying, hey, look at the g graph at -5. And so we go to the g graph, 1, 2, 3, 4, 5. Go down to the graph. What's that?
1. -1.
-1, right? So the answer to this one is -1.
Oh.
The third one just requires you to look at g twice. So we'd like look at g of 9, figure out what that is, look at g again at whatever that g of 9 ends up being. Very similar kind of thing. I wouldn't worry like a ton about these. First of all, these are made harder because these graphs are just sometimes really funky. These aren't horrible. The ones that I got generated aren't horrible, but I teach 50 students and they're all randomly generated. So usually one of them is like very weird. And so I apologize if you got that one. But for the most part, they're usually not terrible. Other questions about this one? All right. Other things currently. Happy to again stand by and wait for you to look at stuff. That's no problem. Let me also just mention too that I post all the quiz solutions on Blackboard. So quizzes are another really good thing to study because those are the kind of questions I'm going to ask. And all those solutions are on Blackboard. I might as well just show it to you because I think I have Blackboard open still. Yeah. As you go to Blackboard, course documents, right where you get the quizzes from each week, I just post the solutions in that same folder after they're due. I usually try to wait until people submit them, give people a chance to submit it, but they're all there now, right? Here's quiz 2, here's the solutions. Quiz 3, solutions. And these quizzes are going to look a lot like the test. That's one of the reasons why I do these quizzes. These are very similar kind of questions, right? So I don't have any general questions about like test protocol. So let me just maybe say a few things. So it's in person. It's going to be in Hammond, as I mentioned, that the main lounge there. There's just desks set up, these distance, all that, masks, etc. I'll be there to answer questions. And let's see, what else do people usually ask? Oh, there's no need for a calculator. I'll bring some basic calculators in case you really want one, but certainly can't use a graphing calculator or any sort of computer or anything like that. Closed notes, other things like that you guys are curious about. TI-30X, let me see. Look up my calculator. Yep, the TI-30X should be fine. Once we start moving into trig, I'm going to ask that calculators don't have trig buttons on them, which it looks like probably the TI-30X does. But again, I always bring basic calculators. Like we can use calculators to add, subtract, multiply, divide, check arithmetic. We're trying to avoid calculators to do course material that we're supposed to be learning about. So yeah, that calculator is fine for this time. But once we move into trig, it won't be. Are you allowing notes? So this particular quiz is going to be closed notes. Everything's open notes until, I'm sorry, tests. This particular test is closed notes. Everything's open notes until tests. I'll consider small note cards on maybe future tests when material starts to build. But this early stuff really needs to be the kind of stuff that you need to be able to do without too much support, like adding fractions, solving equations. We kind of need to be able to do that stuff inside of other problems, right? So we can't be relying too much on crutches during this early stuff. So short answer, no notes during this first test. Once we get into trig and there's lots more memorization, that's when I usually start allowing some reference material. What else? Those are good questions.
Is the test timed?
So I wrote it for a normal class period, a 75-minute class period, and actually wrote it, I think, to more like an hour's length. But that's all relative. So some people might finish it in 30 minutes. People who are really prepared are just going to blow through it. People who need more time, like I was always a slower test taker. I kind of took my time. I often had test anxiety, which slowed me down and stuff. It took me longer. Anyway, what I'm trying to say is it might take people longer. I'm not going to take the test away from anyone. You're welcome to spend as much time on it as you need. But you should, you should do it inside the 75-minute period. That really should be done in that time. But if you need more time, you can take it.
Could we take a look at number 2 on the review questions?
Yep, let's look at that one.
Just the third equation, because I was looking at the solutions, and I'm not sure like how the first step went to the second step.
Okay, so review number 2, 2C, the third one. Let me just see what I wrote in the solution so I can see what you're looking at. So it looks like in the solution I did the method where you multiply these two numbers together to get the thing, blah, blah, blah. Do you do it that way? Do you like that?
I've never seen that method before.
Okay, then let's not try to teach us something new. How do you like doing problems like that?
I usually just guess and check for these types.
That's what I do too, honestly, and that's a totally fine way to do it. Like, it's going to look like this. There's going to be x's here. This is a 7. The only factors of 7 are 7 and 1, so it's going to look like that. Like, that's how I personally approach these problems. And if that makes sense, you do it. These numbers are a little bit tricky. I'm not going to put numbers like 31 and 20 on the test, probably. I definitely not. I do it so that they're more manageable. I don't know why I actually did this on this review. I must have found this problem somewhere and just went with it. But and then you start thinking about like factors of negative 20, right? It would be like 20 and 1 and 5 and 4, maybe 10 and 2, and you just kind of work through them. Usually this one feels like it's probably the right answer. It's usually not like big numbers like that, and then you just try to start filling it in, right? That's how I would approach this one. I'm happy to go through the solution if you want, but I just don't want to like try to teach you something new.
Yeah, I was just confused because I've never seen that method before. I wasn't sure how, the first step went to the second step. So I'm good with that one.
Okay.
Thank
Yeah,
you.
that method's kind of cool. I can't remember when I actually learned it or if it's in the video, honestly. I learned it at Fitchburg State teaching this class. I usually just taught this, just guess and check, and then someone was like, oh, I learned this cool method in high school, and they showed me it, and I was like, oh, that's kind of cool. And it basically just provides a step-by-step method to get those kind of questions for people who really like step-by-step methods. But I don't necessarily recommend that, but it's fine if you want to do that. I mean, I know some people in my class do that. I was talking to some people and they absolutely like that method. So anyway, I'm happy to do this. Yeah, go ahead.
So you can just multiply 7 by negative 20 and just do it regularly, just from there? Like guess and check, I mean, from that?
Sort of. So what you end up doing is like you multiply 7 by negative 20 to get negative 140. Right, so this is the 7 times 20. You like take this and this and you multiply them. And then you factor that regularly, which is not easy to do either because it's a big number, but that factors like that. And then what you do is, you like got rid of the 7 to make this easier to factor. And then you reintroduce the 7 by dividing it back into the fractions. And then you reduce the fractions, but you need to leave them being a fraction, I think. So it becomes like 5/1. This one doesn't reduce. And then this number just moves over here. This number moves over here, and then that ends up being the factored version. It's just like an interesting step-by-step kind of thing.
All right, thank you.
Sure. But again, I would just start sort of guessing and checking and trying to get right down here. And just, I'll say one more time, I'm not going to put numbers like 31 or 140 on the test. I put numbers that are just like, there's like 1 or 2 factors, right? There's not like a ton of stuff to think about, but it still lets me know that you understand how to do it.
Professor, could you move that paper up just a little bit or down? Thank you.
So this will be some good discussion so far. I'm happy to keep looking at specific questions. You know, we can look at like large, big picture stuff, like remind me about whatever, domain and range with the function. I'm happy to sit here and just let you guys look through stuff. You know, what I would, again, sort of recommend is you at least look through maybe the topics and or practice problems for things that are confusing that you don't know how to approach, right? Like if there's a topic on the practice sheet, you're like, I don't even know what that means. I can help you with that, point it out in the notes, go over it. You know, what is this question even asking? That's a good thing, or whatever to be helpful. Just gonna stop talking again here. You're welcome to just chill, but I think that would be the best use of time.
Do you think we could walk through C for 9 on the practice problems?
Yeah, of course, number 9. Let's see here. Okay. So number 9 is the composition question. And it gives us 3 functions, and we want to plug them into each other. Now, I've been spending a lot of time talking to people about composition of functions in general. This is the homework that was due last night. And in the review session this morning, we spent a lot of time on this question. Do people want to hear more than just the last one? Do you want me to give another rundown of composition of functions? I don't want to waste your time if people feel okay about it, but just based on what I'm hearing so far, it seems like that might be useful. Or we just want to look at number 3.
I'd like to hear some more about that, like the decomposition part.
Okay, sure. All right.
Of course, like after this one.
Yeah, no, I understand. Okay, cool. So let me give a quick rundown, and do it like this. So this is how I like to explain it. If I'm going to mess around with the function f, if I want to take the x out of it, it might look like that, right? It's this exact same function, but I'm taking the x out of here, and so if I take it out of here, I also took it out of here. So it's the exact same thing, just without the x. We could do the same thing with g without the x as well, right? So here I am, and let me do it actually down right here. Here I am removing the x from g. So there are the f and the g function, and don't worry too much. Yeah, there's a sign here. Don't worry about what sign is if you're confused. Just trying to introduce sign in this review because we're about to start getting into some trig. But the idea is, if you have these two things without the x in it, right? This is the g function without the x. There's the f without the x. Whatever you write in here, you just fill in the other x. So you could put numbers in there, right? We could do something like put a 3 in, and there'd be 3 in those 2 spots, right? Whatever you put in the blank, you just fill in the other blanks with. It's pretty straightforward with numbers, right? But we can do it with variables or functions or anything. We could plug anything into those parentheses. As long as we do it in one place, we should do it to all 3 places, or all 2 or 3 places. Just break that, almost just broke this, okay. So for example, we could plug in like a plus 1, right? If I put the function a plus 1 into there, it also just goes into where the other parenthesis is. We could do the same thing with like a square root or something, like square root of x. If I put square root of x right here, then it should also go into the other spots. So that's sort of my general overview there. So let's skip part A because it sounds like people don't want to hear about that. But part B then asks for g of something. And so I'm going to mess around with g again. So I'm going to take the x out. And what are we putting into g? Well, part B says put f of x in there. And so if I put f of x in here, it also goes to the other 2 places. Well, we know f of x is 1 over x from above. Right? F of x is the function 1 over x here. And so when I write f of x in those 2 places, it's the same thing as writing 1 over x. So this could become this then. right? This is g of f of x. Now, I know that wasn't the question was part C, but part C involved g of f of x. So that's where I wanted to start there. People okay with g of f of x? So then part C wants h of g of f of x. Now, let me just sort of start by saying there's three things here. I'm not going to put one that has three things on the test, but this is a really good question because if you can understand this question, I feel like you really have a good grip on composition of functions. If this is particularly confusing, maybe work on it a little bit more. I'm not going to ask one like this, but let's look at it anyway. So we're messing around with the h function, right? H is on the outside here, and h is sine of x. So I'm going to write down the h function, but I'm going to take the x out of it. All right, so here I am writing down h without anything in it. Right, I took the x out. There used to be an x here and here. I took them out. Part C wants you to plug in g of f of x. Well, that was the thing that we just found right here. Right, so if I put g of f of x right here, it also goes right here. And that's exactly what this is, this entire thing. So this entire thing then is going into that location. So this should be sine of this. I should do it on the next line, it's a little bit longer. And so you would take that one step at a time. This piece is the g of f of x part. Thoughts on that one? Okay, so let's look at decomposition one if that seems okay. So decomposition is doing the opposite. It's like starting with one like this or one like this and pulling it apart into two separate things. So I didn't write one of these examples on this particular review sheet. Maybe I should have because I oftentimes do ask questions like that, but plenty of them in the homework. You did a bunch of them last night. That would be something like this, like, oh, here is two things that have been plugged into each other already. Right, I'm telling you, two things have already been plugged into each other. Here's what it is. What are the two things that got plugged into each other? Right? What could I write right here such that when I plug it into the variable right here, I end up with the original function? That's sort of what this is trying to get at. And so we think about what does the outside function look like, right? So there's a square root here. That's sort of the outermost thing. And then what's on the inside of it? The inside of it is the x squared plus 1. And so when I'm looking at the outside and the inside, it makes me think that the f has got to have a square root. And then what goes inside of it is going to be the x squared plus 1. Right? If I take this, put it in there, I would get the original. And so f of x then is square root of x. G of x is x squared plus 1. Because when I take this x squared plus 1, I put it in here, it is this, right? Like, let's just do that again because we've done this a couple times already. If this is my f and this is my g, here's f without the x in it, right? And then if I put in x squared plus 1, it just goes in there. And that's exactly what the original thing was.
Why is it not 1?
Why is it not what? I'm sorry?
X plus or x squared, sorry. So right here you have x squared plus 2. I was just confused on why wouldn't it be just another x on the inside? So why wouldn't it be x plus 1 instead of x squared plus 1?
So another thing you could do, I'm not sure I totally understand, but maybe this will clarify it. Another option could be f of x equals square root of x plus 1, and g of x equals x squared. So then if you put this into there, it would also be the original. I don't know if that helped. Do you want to say what you said again? You said x plus 2 or something, but I don't see an x plus 2.
Or so basically I was just confused on, wouldn't it make sense if the x's combined to make x squared? But then I realized it's substitution, so that means it wouldn't have worked. It needed to be x squared. I figured.
I see what you're saying. Yeah, you're not like taking something.
You're not adding.
You're not like multiplying them. You're plugging one into it. Yeah. So maybe you were thinking like, I guess this, and then you were sort of thinking x plus 1, because then if you did it, you do like x times x plus 1. And you get x squared or something. But that's not what's happening, right? You're taking this one out and you're putting this into it. Yeah, it sounds like you thought that one correct. Okay. Other thoughts about this sort of concept? There's two versions of the composition ones, right? There's plenty in the homework, and I want to be clear about that. But I actually haven't gone through your homeworks that were just due last night in detail yet, so I haven't figured out if there's issues with that one. I guess I could take a look right now. But feel free to ask another question.
I did have a question, but it's one that we already went to. Number 2, why did you just bring the 7 and multiply it to negative 20 on the factoring ones?
Yeah, I really don't want to confuse people on that. That's a method that you can use to solve these types of equations. That's just one of the methods that could be used that I don't necessarily recommend, but someone was just asking to see that method, and that is actually how I wrote the solution for this one in the solutions, is what this person noted. That's why I did that. If you like doing it another way, just do it another way, the guess and check way, and we can talk about the method if you want. But I don't want to like teach something new the day before a test as well. Even though I realize I kind of did that in the solutions.
Yeah.
Do you want me to? I mean, I really don't want to confuse people. It sounds like I already confused you by talking about that. So
yeah, no, I was just confused on like the why. I wasn't really trying to jump into it. I was just like, how would I have seen that and just been like, so I'm gonna just multiply it to the back variable?
Because there's like one of a few methods that is the first step of doing that method. Is the short answer of it. But we don't need to talk about that if you don't want to. I think we should just avoid that, honestly.
All right.
The question that you're going to see more in like on the test is going to look more like 2x squared. Oh gosh, I don't know. Let's see, like 1 plus 5x plus 3. I'm not even positive that can be factored, but that's a little bit easier to think about because it's only a 5 and a 3 rather than a 31 and a 140 or whatever the original was, 31 and 20. So focus more on questions that are a little more straightforward, like this one. I'll have to rethink this review sheet. That's obviously not a good question to put on this review sheet, and it's caused some issues. I apologize for that. I'm just going to remove this before it gets anyone else confused.
Professor,
Blue.
could we do 5 like the first one?
Yes, we can. So what are we trying to avoid here?
Square roots and negative and 0.
What about 0?
Can't be equal to 0.
What can't be equal to 0?
The denominator.
Right. Yeah, so we want to, in this particular problem, avoid dividing by 0, which means we need to avoid the denominator equaling 0.
Mhm.
So how do we solve that, right? So quadratic equal to 0. 2 options for solving that. What do you think?
Mm. I don't know.
So you can either factor it,
Okay.
or we can always use a quadratic formula for these things.
Yeah, I mean, okay. I completely just goofed out on that one. Oh.
So this is a factorable one because they both have an x.
Yep.
We can just factor this one
Mhm.
like that. And then what do we do?
What x?
I'm sorry? So, I mean, this is a problem that's similar to the other problems in the review, like number 7, the ones on the left there, right? Quadratics equal to 0. Definitely got to know how to solve these things.
Oh, I mean, like I know how to do it like with the quadratic formula.
Okay, well, what if it's factored like that?
Then distributing the x to the other x, and then 4x.
That's going to get you back to here.
Yeah.
So what you do is you set them equal to 0 separately.
Oh, okay.
So this is one of them. Add the 4. This is another thing. So we're trying to avoid to really be not equal to 0, right? We want these things to not be 0.
Hmm.
So we want x to not be 0 or 4.
Okay.
So what does that look like as a interval?
Going to imagine bracket or no parentheses, I'm guessing.
There's not going to be any there's going to be all parentheses. Here's what it looks like. I'm skipping over 0 and 4
Hmm.
in circles. So what's it going to be?
Parentheses, negative infinity
Mm-hmm.
to 0, right?
Yep.
And then that's a gap, right?
Nope. This is a second piece.
Okay. Then
So first of all, parenthesis here,
yeah,
right? Open circle. Then what?
Then O to 4 or 0 to 4.
Yep. Both parentheses again because
Parentheses again.
Circles. And then what?
And then 4 to the rest of it, infinity.
That is it.
Okay.
Yep.
Cool. All right.
So we are nearing the end of class here. It's 3:13. I'm happy to stick around and answer some more questions, but around 3:15, I'm probably going to sign off. So there's other things you want to look at, please let me know. But, before we sign off here.
No, I'm good. I'll talk to you tomorrow, Professor.
Okay, thanks.
Could we go over problem 7 and the last one? So I guess 7D. It's the 1 over 13x plus 4 equals 8.
Yeah, so this is a fraction question. The x is in the denominator, and so we want to get the x out of the denominator. How do we get rid of denominators?
So we multiply it by itself. So 13x plus 4 times 13x plus 4, and you have to do the same to the top as well, and to the other side.
So we just want to do this. We multiply
Yeah.
both sides by the denominator. It sounded like maybe you were trying to multiply the numerator and the denominator by this, but we're just doing this.
Yep.
These cancel, right? And then you get 1 equals distribute, what is that, 80 plus 24, 104. There should be an x there. 8 times 4, 32. Does that seem all right?
32. Yeah, that seems right.
Okay. Then this is now kind of an easy thing, right? Subtract 32. Move over here. We'll get minus 31 equals 104x. Divide by 104.
Okay, thank you.
Sure.
For number 5, the second one, I got a different answer than what you got in the solutions, because I thought that that x also couldn't equal 0 because it would be dividing by -7. I mean, being the square root of -7. So I was just confused about that one.
What did I just do with that one? This one right here, the one that we were just looking at.
No, the one after that, the square root of 12x minus 7.
So square root of 12x minus 7.
Because I thought it couldn't equal 7 over 12 and also 0.
So if you plug in x equals 0, you just get. Oh, I see what you're saying. So here's what you do. Did you set this equal to 0? Is that what you did?
Yeah, I did, and I got 7 over 12, but then I looked at it, and it looks to me that you can't have x equals 0 because it's going to be -7.
Yeah, so you're missing something here. So we set the other one equal to 0 because we wanted to avoid dividing by 0. So we were trying to figure out when does the denominator equal 0. That's why this was an equal thing. If we're trying to avoid square rooting a negative, we need what's inside there to be not negative. So we need 12x minus 7 not to equal 0, but to be bigger than or equal to 0, which is what I do in the solutions.
So why can it equal 0? Like x equals 0.
X can't be equal 0, right? When you solve this inequality, you get x has to be bigger than or equal to 7/12.
Oh, I see. Oh, okay. Okay.
Right, so that's bigger than 0. It's also bigger than 7/12. So for example, x can't be 0.1. X can't be 0.5. It needs to be bigger than 7/12 in order for this to work.
All right. That makes sense. Thanks.
Sure.
All right, thank you, Professor. Have a good day.
All right, take care.
Yep. I'll see you tomorrow. Thank you.
Okay, bye.